So hello everyone, welcome back to another particular lecture series of our photochemistry course, and this is the class 4. And in this particular class we are extending our discussion about the Norrish Type I reaction. So in our previous discussion, that is the class 3, we are talking about the Norrish Type I reaction in details. So now this is the continuation of the previous lecture. Here we are talking about the Norrish Type I reaction for some kind of cyclic system, and then we are talking about the solvent effects. Okay. So first of all, let us understand that how the solvents is actually influencing the product of the Norrish Type I reactions. So basically, in case of polar protic solvents, such as the ether or alcohols, this type of solvent are actually predominates to the ketene formation, followed by the ester formation. So what should be the mechanism of the particular reaction? Like this is the cyclic ketone. The first process is the alpha cleavage takes place, and after that the acyl alkyl radical has been generated. Now in presence of the solution state, especially in the alcohol state, if the ROH is there, so what happened that this particular hydrogen from the acyl radical is captured by this alkyl radical, and then it leads to form a ketene, as we already discussed in the previous class. Now, in presence of this type of solvent, this process is mainly favored, and after that, this particular alcohol are actually attacks here, and it will undergo a certain rearrangement to generate the corresponding ester. And this type of ester formation is predominant in presence of the polar protic solvents. Similarly, if we talk about the regioselectivity of the particular reaction, especially the cyclic one, then obviously the alpha cleavage site is depend on the alkyl radical stability, as the similar concept that actually used in the acyclic systems. Like here in this particular compound, here you can find if the alpha cleavage takes place via this black bond, then what happened, the resulting alkyl radical is the secondary radical. Whereas if it is the alpha cleavage takes place via this particular red bond, then the resulting alkyl radical is a primary radical. And we already know that the secondary radical have the much more stability over the primary radical, and that's why the alpha cleavage is the regioselective in nature in terms of cyclic ring also. Now, for example, we can take certain example, like here you can find the alpha, initially the alpha cleavage takes place. So this all are H nu. So initially the alpha cleavage takes place here and generate the acyl and alkyl radical. And also this particular group has a cyclopropane ring. And we already know that cyclopropane rings are very, very reactive due to this particular ring strain and angle strain. To eliminate the ring and angle strain, it actually undergo reactive. So after generating this biradical, the acyl alkyl radical, then this particular bond is undergo homolytic cleavage. And after that, it will show a recombination to get this type of product. And similar type of reaction is observed in presence of an external epoxide ring present. Like the epoxide ring is also none other than a modified cyclopropane ring, we can say. So it will also undergo this type of recombination reaction to form this type of cyclic esters. Okay. Now let us talk about certain more example with this type of complex system where initial alpha cleavage is regioselective, where this particular center you can find that a tertiary radical has been generated, which alkyl radical is generated, which actually facilitate the alpha cleavage, and then the ketene formation takes place. And since it is a polar protic solvent is here, as I already discussed in the slide 1, that in the case of polar protic solvent, the ketene formation takes place, and then after generating the ketene, this will undergo nucleophilic addition of this particular ketene carbon, and undergo rearrangement, it will generate this type of esters, and this will be the final product. Now there is another example where basically this is our starting material and it is in the undergo photochemical reaction. And interestingly, here is no concept is no solvent is given. That means we can assume that the particular reaction is undergoing a gas phase reaction. So for the gas phase reaction, I already know that all kind of gas phase or solution phase, no matter, initially the alpha cleavage takes place. So the alpha cleavage, after the alpha cleavage, the regioselective cleavage, this two radical is generated. And since it is a gas phase reaction, in the case of gas phase reaction, the decarbonylation gets more priority. So the decarbonylation takes place to generate these two radicals. And now we already discussed in our previous slide that the cyclopropane rings are much more reactive in terms of UV light because of the ring strain present in the cyclopropane ring. So this particular bond is undergo homolytic cleavage, and then the two radicals are generated, and these radicals are getting recombined such as to get this our major product. So I hope these examples are clear to you. Next, we are talking about certain interesting concept where the 1,4-acyl alkyl biradical is generated. For example, you can take this particular cyclobutanone system. Now, in presence of light and the polar protic solvent, what happened? That this type of first the alpha cleavage takes place, and after alpha cleavage, we can say that this type of 1, 2, 3, 4. So 1,4-acyl alkyl biradical is generated. Now, in presence of the polar protic solvent, the most common is to generate the ketene. But in this particular case, when this type of 1,4-acyl alkyl biradical is generated, then actually a ring expansion occurred. That means this particular alkyl radical are here not taking this particular acyl hydrogen. Moreover, it will attack in the particular oxygen center and make this type of system, like ring expansion takes place, and here is a carbene type of system is generated. Now, this will go a nucleophilic substitution to the solvent to generate this type of compound. So this is called the oxacarbene. And after that, this particular center actually attack with the particular solvent to generate this type of compound. So this type of compound is very, very interesting, and you have to remember that particular reactions. Next, we are talking about another examples where this type of norborelline system is there. Initially, the alpha cleavage takes place, and also it is a similar kind of acyl alkyl biradical type of system is generated. Now, since it is generated, that means without taking the ketene formation, it will undergo ring expansion. Okay, so it will undergo ring expansion, and we get this oxacarbene type of system here. And then this particular carbene center are actually attacked in the polar protic solvent to generate our desired compound. So this is something that you have to remember, the type of reactions. So with this, we are actually completed our Norrish Type I reactions. So in the next class onwards, we are talking about the Norrish Type II reaction. So thank you for listening.